Okay. So, let us continue the discussion of the solution of A equals to B, and what we are trying to answer is that whether what is the possible vector B where we can find solution or to have a solution. Essentially the condition for B that this has to belong to the column space. So, then only we can have a solution. Then the next question that we have raised here is that what is that vector which can give us the 0 solution. So, the vectors which will actually provide the 0 solution, that would belongs to null space. Now, continuing with the same example or keeping the same example in mind, let us say if our B is 1, 2, 3, 4, then the possible solutions could be 1, 0, 0, that is one possibility, or it could be 0, minus 1, plus 1. So, that means as I said, for a particular B, the vectors would be. So, the question is formation of the subspace by two solution for a specific B. So, the solution vectors here will not form a subspace of R3, because the plane which are formed by the vectors, that does not pass through origin, and also 0 vector does not exist. So, that means we have a particular B. So, previously we have C for 0 solution. So, this is a particular solution vector, but here we have a particular B and we have a solution vector, but now these solution vectors they basically do not form subspace of R3. That means, to form a subspace of R3, we have already mentioned these conditions what is possibly there. If you just refresh that, to have a subspace of that the plane formed by this vector that does not pass through the origin, or there is no 0 vector which actually exists there. Now, our goal is to get a solution for A x equals to B, or solve A x equals to B. And what is important here, if B lies in column space of A, then only solutions are available. Okay. So, that means to have a solution, B has to lie in the column space, and then only solution is possible. Now, there is another one which is that null space vector. So, the column space are formed by column vectors of the null space vector is the column space are formed by column vectors of coefficient matrix. Okay. So, we can again look at an example. Let us say we take a different example of 3 by 4 system, which is like 1, 2, 2, 2, 2, 4, 6, 8, 3, 6, 8, 10. So, what we can actually look at here is that this particular example column space of A belongs to R3, and also if you look at carefully that that there are 4 columns, but or column vectors, out of that 3 are independent and 1 is dependent. So, out of these 3 vectors are linearly independent and 1 vector is dependent. That means the any combination of that other 3 would form the 4th one. So, here what we are trying to find out is that we want to find out the null space vector. Okay. So, typically or in general this is obtained through the elimination process again, and idea is to form the upper triangular matrix. So, here if we do an operation like R2 minus, so R2 equals to R2 minus 2 R1, and then we get 1 2 2 0 0 2 4, and also R3 equals to R3 minus 3 R1, which will be 0 0 2 4. Now, the further operation on R3, which is R3 minus R2, which will give us 1 2 2 2 0 0 2 4 0 0 0 0. So, this is not an, obviously this is not a proper upper triangular matrix. So, this is rather called as echelon form of matrix, echelon form of matrix. So, since it is not an symmetric one, so we get an echelon form of the matrix or matrix A. Okay. Here if you look at that, there are 2 pivots which are there. This corresponds to x1 and this corresponds to x3. Now, what we are trying to find out? We are trying to find out the null space vector. So, that means the solution that we are shooting for is Ax equals to 0. If we do this here, what we end up getting is that x1 plus 2x2, 2x3 plus 2x4 is 0 and 2x3 plus 4x4 is 0, and we get x1 and x2, x3, these are the 2 pivots which are sitting in this echelon matrix actually, or in the echelon form of this matrix. Now, we get, once we do this elimination process, we end up getting these pivots, and the pivots actually, whatever the pivots which are there, these pivots are going to determine the rank of the matrix. So, the rank of matrix would be the number of pivots. Here 2, so the immediately one can say that the rank of this particular matrix which is taken as an example is 2 straight away, since the number of pivots are 2. And the columns, these are the columns, first column and the third column. The corresponding columns with the pivots are called the pivot columns, and other columns like these and these are called the free columns. So, as soon as we determine, so we have like, let me write down this echelon form which is there, and then it would be easier 1 2 2 2 0 0 2 4 0 0 0 0. So, this is 1, this is the 1 correspond to x 1 and x 3. So, with the pivots, these are called the pivot columns, where the pivots are sitting, and others are the free columns, and R is the rank of the matrix, which will be the number of pivots sitting there in the echelon form. So, if we have now if we try to generalize that, if we have a m by n system and rank is R, then we have independent variables which are n minor R. Okay. And so, for this particular example, the number of independent variables equals to 4 minus 2, which is 2. Now, here if you see, the free columns are the second column and the fourth column. So, the variable x 2 and x 4 are taken as independent variables, as they correspond or belong to free column. Okay. So, we can take any value for x 2 and x 4 and we can find out the solution. For let us say we take x 2 equals to 1 and x 4 equals to 0, which will give us x 3 equals to 0 and x 1 equals to minus 2. Similarly, we can say, or we can have x 2 equals to 0 or x 4 equals to 1, then that will give us x 3 equals to minus 2 and x 1 equals to 2. So, we can get any solution in this particular form, where x would be c into minus 2 1 0 0 plus d 2 0 minus 2 1. So, the solution would be in this particular form. Here c and d are any scalar which will give us any combination of the solution. Okay. Now, these two vectors which we get here, this guy and this guy, these are called the basis vector. Okay. And since they form a two dimensional subspace, because there are only two basis vector. So, it depends on how many basis vector you have. So, since there are only two basis vector, so they form a 2D subspace in R4 or 4 dimensional vector space. Okay. So, there are two basis vectors. So, now we can little bit do further more calculations, or like from here if we do further operations like R1 equals to R1 minus R2. So, some more elimination just above and below pivot, which will get us 1 2 0 minus 2 0 0 2 4 0 0 0 0. Now, what we will do is by 2 1 2 0 minus 2 0 1 2 0 0 0 0. So, this guy here is called row reduced echelon form of A, and once we do that, from this guy the equation becomes, from here if we write, the equation becomes x 1 2 x 2 minus 2 x 4 is 0 and x 3 plus 2 x 4 is also 0. So, we can rearrange this. So, once we rearrange the things, what we can write is that let us say 1 0 2 minus 2 0 1 0 2 and 0 0 0 0. So, what we have done is that we just interchange the columns. So, which means this would be x 1, this would be x 3, x 2, x 4. So, here we can see this is a block of identity matrix, this is another block of free variable. So, one can write this one as identity matrix, free variable 0 and 0. So, here if we do that guy with minus f and I, then this would give us always 0, and this particular form is called R, which is the row reduced echelon form, and this is my null space vector, which will give me 0 solution. That means, the row reduced echelon form multiplied with the null space vector should be giving me 0. N here is the null space, or called the null space vector. Or other way, I can write I f free variable pivot variable would be 0. So, x f plus f x p would be 0, and we get x f equals to minus f x p. So, here x f as the free vectors, x p as the pivot vectors, okay. And f means free matrix element, free matrix elements. So, this is how you can get the row reduced from, and from there you can find out the null space vector. So, let us take another example and find that. Let us say A is just 4 by 3. So, just reverse this one, this would be 1 2 2 2 2 4 6 8 3 6 8 10. So, we have 4 rows, 3 columns, and again if we do the operations here, let us say R 2 is R 2 minus 2 R 1, R 3 is R 3 minus 2 R 1, and R 4 is R 4 minus 2 R 1. What we get here is that 1 2 3 0 0 0 0 2 2 0 4 4. Now, we do the exchange of row, like R3 is R2, then what we can write 1 2 3 0 2 2 0 0 4 4, okay. And then further operations like what we do R4, which is R4 minus 2R2, which is like 1 2 3 0 2 2 0 0 0 0 0 0. Here again you can see this guy and this guy, these are sort of pivots and the rank is 2. Now interestingly, this particular example is the transpose of the previous one. So previously we started with 3 by 4, here we started with 3 by 4, and the same one we just reversed it 4 by 3, and you can see the rank of that matrix. So the whether it is A transpose or A, the rank remains same. From here we can write x1 plus 2 x2 plus 3 x3 is 0, and 2 x2 plus 2 x3 is also 0. Here we have 3 variables, which is x3, and let us say x3 equals to 1, then we get x2 equals to minus 1, x1 equals to minus 1. So the solution would be C1 minus 1 minus 1 1, where C1 is any scalar. Now from this particular matrix we will do little bit more operation, where we have 1 2 3 0 2 2 0 0 0 0 0 0. So we do little bit of more operations like R1 is R1 minus R2 and R2 equals to R2 by 2. What we get 1 0 1 0 1 1 0 0 0 0 0 0. So this is what it is R, row reduced echelon form, and here the vector which is this is the basis vector which is minus 1 minus 1 1, which is giving us the 0 solution, or the vector which belongs to the null space vector, and the null space vector is any linear combination of that which is minus 1 minus 1 1, and this one is the basis vector. And you can see the one vector which is forming this null space. So this is forming essentially one dimensional subspace in. So this example is this. So column space lies in R4 and null space in R3. So the null space is forming, the basis vector is forming one dimensional subspace in R3. Now we continue with the previous example to find out the solution for Ax equals to b. Now obviously for solution of any Ax equals to b, b has to belongs to column space of A. Okay. And the previous example, what we can see, the previous example means we are talking about this one only, this one only 4 by 3 systems, where we can continue and we can say that here this is column 1, this is column 2, this is column 3, then we can say C3 minus C2 minus C1 would be 0. So, which means there is a restraint of that B 3 minus B 2 minus B 1 would be 0. So, this is one can see by looking at this guy that C 3 minus C 2 minus C 1. So, this would be the restraint there, but this particular thing, this conclusion should arise from the elimination process. So, let us augment the matrix and do the thing. So, if we augment the matrix, what we can write is that 1 2 2 2 2 4 6 8 3 6 8 10, and then we write B 1 B 2 B 3. So, we are going back to this 3 by 4 system. Now, here the operation is R 2 minus 2 R 1, R 3 minus 3 R 1, which will give us 1 2 2 2 0 0 2 4 0 0 2 4, and this is B 1 B 2 minus 2 B 1 B 3 minus 3 B 1. Now, the further operations on this, which is R 3 minus R 2, which will get us 1 2 2 2 0 0 2 4 0 0 0 0. This is B 1 B 2 minus 2 B 1 B 3 minus 3 B 1 minus B 2 plus 2 B 1, which would be B 3 minus B 2 minus B 1. So, from the last row, it is evident that B 3 minus B 2 minus B 1, this has to be 0. So, this is a necessary condition to obtain a solution. So, if say let us take B 1 equals to 1, then B 2 would be 5 and B 3 would be 6. So, the equations becomes x 1 plus 2 x 2 2 x 3 plus 2 x 4 equal to B 1, which is 1, 2 x 3 plus 4 x 4 would be B 2 minus 2 B 1, which is 3. So, the final solution vector should be the sum of pivot variable and the free variable. Okay. So, in particular solution, the free variables, let us say for in particular solution, say x f equals to 0, which is x 2 x 4 equals to 0, then what happens is that x p will become minus 2 0 3 by 2 0. So, which is x 1 plus 2 x 3 equals to 1, where x 3 equals to 3 by 2. Again you have a x p, which is b, and a x f, which is 0. So, a x p plus x f should be b. So, the complete solution would be x p plus x f, which is minus 2 0 3 by 2 0 plus C 1, which is minus 2 1 0 0 plus C 2, which is 2 0 minus 2 1. So, this one we get by setting a x equals to 0, and this one by making free variable to be. So, the free variables are basically the null space vector, and the solutions will be available provided rest of the conditions are satisfied. So, you can see that the solution could be getting into the both the particular and the pivot variables. So, this is how you can actually get a solution with the combination of the free variable and the pivot variable. We will stop it here and continue the discussion in the next class.